finding the inverse. Now when you're finding inverses, it's the one case where I'd rather use y than f of x.
All right.
What's the first step?
Multiplying both sides by...
No, there's two steps.
No.
Two steps to finding an inverse. What's the first one?
Flipping the x and y.
Yeah, and then just solve for y, the second step. So it's really almost the two easiest steps you can think of. Now the algebra isn't always easy, and this algebra is not the easiest, but okay, now we got to solve for y. Here, let me make some room. Now how do I solve that for y?
Then you multiply both sides by 3 minus 2y.
Okay, that gives me 3x. Excuse me, sorry.
Good.
Now what?
Now, would you just take the 2xy, move it over to the other side?
Yeah, gather all like terms. And in other words, any term that has a y in it, I'm going to put it on one side. Everything else goes on the other. Now what?
Now you factor out a y?
Yep. And this is as tough as it gets, really. And that's the step that everybody has difficulty with, is gathering all the terms with y on one side and factoring out a y. So the final step,
Is it just multiplying both sides by 5 plus 2y, or 2x?
dividing both sides is what you meant.
Oh yeah, dividing.
Because it's a multiplier right now, so you always do the opposite. And there's your inverse. In other words, that is the inverse of what you started with.
All right.
And you can see that it's not that easy to just do it in your head. In other words, I'm never able to do these in my head. I always have to go through this process, the complete one, to see what the answer is.
So there's no like quick way to do it?
Well, it kind of looks like there might be a quick way, right? In other words, we're looking at all the same numbers, only that number over that variable over that number plus that. I don't know. If my life depended on it, I would never do it that way. Plus, I don't know what that method is. There might be a quick way, but I don't see it.
All right. Because our test is fully multiple choice, and so like if that was like the last like problem or two,
Yeah, I'm not sure that would help that much on this. If we look at the multiple choice answers, well,
I mean you can immediately take off A.
True.
And
D.
D.
So you know it's down to B or C, but they look an awful lot alike. I guess if you had to guess, you'd go with the sign that's opposite that sign, which is the correct answer. But I don't know. I don't think that you can come up with a system like that. Maybe. In other words, if that was 3 plus 2x, you think this would be the answer? 5 minus 2x?
I mean, yeah, because you have to switch it over.
Well, maybe. I'm not positive that that's the case. But let's look at the second one. Which of the following equation matches the graph? Oh, here. I always forget I can do this. In other words, in order to get the graph and the question on the same viewing screen. So clearly that graph is a greatest integer function.
Yeah.
Has it been flipped over the y?
Yes.
No, the open loop would go to the left.
Oh.
In other words, if...
No, it's flipped over the x.
Well, it might be flipped over the x. I haven't gotten to that yet. But here's what the greatest integer function looks like. It's always the closed dot goes to the open dot on the right, like that. So if I flip it over the x, the open dot stays on the right. If I flip it over the y, the open dot goes on the left. So I know it's not flipped over the y. What's the easiest way to answer this question? And there really is a fairly easy way to answer it.
It's just kind of like you cross out the ones that
Pick
don't.
a number. Pick a number and see if it works.
Okay, so like 2.
Okay, so when x is 2, what should y be?
It should be...
According to the graph.
It should be -2.
No, let's see.
Oh, no.
I'm starting there. There's
No, it's -4.
No, actually -5. You got to go to not the open circle, but this.
Yeah, I did. Your counting's off. It's 4 lines. The 5th is for the one below the 5. So it is
1, 2, 3, 4. You're right. So as x is 2, y is -4, right?
Yeah.
So when x is 2, y is -4. Well, let's just go through each of these. A. When x is 2, what is y?
that's +4. No, that's +2.
Right. No, it's -2. In other words, when I plug in 2 for x, I get 1 minus 3. What's the greatest integer of -2? Minus
-2, and then that negative in front of it.
makes it +2. You're correct. So A is not right. How about B?
That would be 1. That would be -1.
Right. I mean, we gotta get at least close to 4. What about C?
That would be 5.
Correct.
Or -5. Oh yeah, 5.
That's 5. That's 5. D?
That would be -2 or 2.
Oh, greatest integer, in other words, if I plug in 2, then I got the greatest integer of 1, which is 1, with a negative sign in front of it. So now I have -1 minus 3. There's -4. Now,
Okay.
that doesn't prove it's the correct answer because this could also be -4. So we kind of have to check this one also. But when I plug in 2, I get the greatest integer of 4, which is 4. -4 minus 3 is -7. So that's not it. So the only one that gave us -4 as an answer was D. Now, I could go back and analyze this completely different. I didn't need to back solve it. I could look at each of these. Let's look at D. Okay? First thing we see about D is a reflection over the x-axis.
Yeah.
Second thing we see about D is it's a horizontal expansion by a factor of 2, right?
Yeah.
And the third thing I see about it is that it's a vertical shift down of 3 units. Well, if I look at this graph, that differs from my standard not by a lot. This one, each one is 2 units wide, so it's been horizontally expanded by a factor of 2. It's been flipped over the x-axis, which is kind of hard to see. In other words, a flip over the x-axis and a vertical shift look very, very similar when you're looking at greatest integer function. It's hard to tell the difference between a horizontal shift and a vertical shift. And
It's just the way the dots are faced. Is the difference, or?
no, let's look at this. Let me try to explain it a little better. There's my greatest integer function, okay?
Yeah.
That's y equal greatest integer of x. Well, in blue, I'm going to shift everything down 1 unit. Okay, so that's what I get if it was -1.
Yeah.
Well, notice that also that's the same thing as if I move everything over to the right 1 unit. In other words, if I take my red function and shift it laterally to the right, it's the blue function. So this is the same as that. That is the same as this. Even though one is a lateral shift, 1 unit to the right, and the other is a vertical shift, 1 unit down, you end up with the exact same function. So just if I showed you just the blue function, there's 2 answers. There's probably a lot more than 2. In other words, it could be either this one or it could be this one up here. So these shifts don't always have a single answer, especially the greatest integer function. It's the one that's probably the most confusing to try to figure out by looking at just the curve. That's why my inclination was to back solve it from the beginning, because it's really hard to figure out what each of these translations does and the effect it's going to have on this thing. Even though we were able to do it, it's almost easier to just back solve. In other words, once you do the translation, if you're trying to check whether you've done it correct or not, let's say they gave you this was the function, graph it. Well, you'd come up with this graph, but the final proof of the pudding is plug in a point and see if you get the proper point. That's the way you want to kind of do all of those, is by plugging in a point to check your answer. Okay. This limit, if I plug in directly, is going to be 0 over 0. Bottom is 0, the top is 9 plus 9 minus 18, so the top is 0 also. So what's the solution?
Wouldn't it be, don't you have to factor out,
Okay.
or not factor,
No, you're right. Factoring is the primary way to solve these. There's 2 techniques. There's factoring and there's multiplying top and bottom by the conjugate. If you get something nasty looking like this, in fact, I just had this problem, and that's your bottom or your top, well, I can't factor that, but I can certainly multiply by the conjugate. So remember those two techniques. Well, this is factorable. What's the top factor into?
X plus 6, x minus 3.
Remember that the bigger factor has to go with the sign of the middle term, because what's happening is that I'm always getting the middle term by multiplying those. Well, I better have a plus in the middle term, and I do. How do you factor the bottom?
Isn't it x minus 3 and then x squared minus
Plus
3x?
Mine is always opposite. When I'm dealing with difference of cubes or sum of cubes.
Oh, so it's
Quadratic is always the middle term has the opposite sign of the first term.
So is it plus 3x or plus?
Yes, it's plus AB, and AB is 3x.
Okay, and then plus 9.
Correct. Okay, now what can I do? I can do that. Now when I substitute 3, I know I don't have 0 over 0 anymore, because I can see the top does not go to 0, goes to 6. So what's the bottom go to when I substitute 3?
27.
Now I can divide top and bottom by 3. I get 2/9. Yeah, I had really a very, very interesting limit problem with the previous student, that you had to multiply by the conjugate, and after doing so, you still had 0 over 0. And then you had to factor. And then that got you the right answer. But I've never had a problem like that before. It's pretty interesting, actually.
And it's 9 on top. It's not 6. Because it's plus 3.
Right, you're right. So it's 1/3.
Yeah.
Okay, thanks. What was that? That was number 3.
Number 4, I understand how to do. It's not that difficult.
So what is the answer for 4?
It's actually A. I just kind of was circling the wrong answer because when you just do X, you kind of just get rid of everything after it, because after the X.
The only terms that matter are the x squared in the numerator and the x cubed in the denominator.
Yeah, so
that just goes to 1 over x. In other words, if I have x squared over x cubed, that becomes 1 over x, and now as x goes to infinity, the bottom blows up and the whole thing goes to 0. Number 5.
So when you just take the x squareds, or the squared numbers, and then if they're plus, then it's either an ellipse or a circle, and then they have to be equal for a circle. So
correct. Exactly correct reasoning. So what is this? This has to be an ellipse.
Yeah. So then.
Right. I see an x squared and a y squared. That immediately says it's not a parabola. And different coefficients. There's a 16 there and a 9 there. That tells me that it's not a circle. And the fact that there's a plus sign between them tells me that it's an ellipse. Because for it to be a hyperbola, there would have to be a minus sign in front of either the x squared or the y squared. Not necessarily one or the other, but one of them would have to have a negative sign in front of it.
And then parabola is only one squared number?
Yeah, exactly. Okay. In other words, take away the square from that y and you're looking at a parabola, because now I got y and an x squared.
Then if both of them are negative, is it still an ellipse or a circle?
It's still an ellipse. Why? because I can divide both sides by -1.
Okay.
In other words, if I told you this, if I gave you that equation, well, if I divide both sides by -1, that turns positive, positive, negative, and now I'm looking at an ellipse.
Okay.
I can give a good example because this is a degenerative ellipse, I think. A degenerative ellipse being there's no way I can make it equal to +1. So I really should have started the problem out by saying that that was equal to -1. And now you can divide everything by -1 and you end up, you're looking at an ellipse. So yeah, if there's one negative sign only, no matter which variable it's in front of, it's going to be a hyperbola.
Yeah.
Okay, number 6. All of these we have to complete the square. So let me write it first of all so I can expand it. 16x squared minus 64x, oh this is going to be a good one, plus 9y squared plus 54y plus 1 equals 0, and now we'll solve this. So what are we looking at first of all?
It's an ellipse.
Okay, so the equation of an ellipse needs to look like this. And maybe the a squared goes under the y, I don't know yet, but it needs to look something like this. Okay? So in order to convert our polynomial to this format, we need to complete the square. Okay? In order to complete the square, I'm going to put parentheses around all the x terms and around all the y terms. I'm going to take the 1 to the other side. Now that in itself does not make for a degenerative conic. Just because it starts out with a -1 doesn't mean anything. What's the next step in completing the square?
Would you factor out a 16 from the x one and a 9 from the other one?
Correct. And the secret to these is always make sure that you haven't changed anything. In other words, is this equation exactly what I just had? And it is. In other words, is this the same as this? Yes, you can multiply it in your head back together again and you can see that that's exactly what I started with. Now, complete the square inside the x parentheses.
So it would be plus 16.
Remember, you take half of that and square it.
Oh, so it would just be plus 4.
Now, how much did I just add to the left side of the equation?
64.
So I got to add 64 to the right side of the equation also. Now, complete the square on the y's.
Plus 9.
How much do I have to add over here?
81.
Okay, now I can write this as 16. The whole point of completing the square is so that I can write that as a linear term squared. So how do I write the y part?
Would it be x plus 3?
Y plus
Y plus 3, yeah.
Okay, then add all these numbers up and I get 144.
Yeah.
Now what? In other words, I still haven't changed anything. what I'm looking at right here is the same as what I started with.
Then you divide both sides by 144.
Correct?
Yeah.
What's the left part become?
It's x minus 2 squared. And then isn't 16 divided by 144 like 9?
Yeah, the 9 goes in the bottom. In other words, 16 over 144 is the same as this, 1 over 9. And this one would be, the 16 would go in the denominator. In other words, 9 goes into 144 16 times. And now I have almost the perfect equation. Certainly as an ellipse whose center is at 2, negative 3. What's A and what's B?
16 is a.
16 is A squared.
Yeah, a squared.
So
A is 4.
And B is 3. You correctly surmised that A is under the Y because A is always bigger than B in an ellipse. Not in a hyperbola, but in an ellipse only, A is always bigger than B. So is this a horizontal or a vertical ellipse?
It is a vertical.
Yeah. In other words, the long side of the ellipse is on the y-axis. And there's the middle of the ellipse. So it's going to look something like this. And the reason I know that it's vertical is that's A. And that's B. A is always the long radius of the ellipse. The longest radius, so to speak. And if that measurement is along the y-axis, then A has to come under the y variable.
Yeah.
What's C? C being the distance from the center to the focus.
Is it A minus B or is it A plus B?
No, you're right. It's not the same as the Pythagorean theorem, but it's close. Pythagorean theorem would be A squared plus B squared. This is A squared minus B squared for an ellipse. Now, for a hyperbola, it's exactly the same as the Pythagorean theorem. For a hyperbola, it's C squared equals A squared plus B squared. So what is C here?
The square root of 7.
Good. And it actually is plus or minus because there's two C's. There's this C right there, and then there's the other C down there. And notice that the one is in a plus direction, the other is in a minus direction. Which one was that? That was
6.
6, okay. And A was correct, yeah. You just make one up that's not real obvious what the answer is, but it's kind of clever. Very few people can get this. I'll see if you can get it. What's A and what's B?
Isn't it just 1?
No?
Yep.
I need to make the numerator 1.
Okay, so
if I divide by 3, top and bottom, most people would immediately say, well, that gives me that, but it doesn't. If I divide top and bottom by 3, I get x squared over 1/3.
oh,
That's the same as this. Notice that if I flip and multiply, I get 3x squared. So this becomes y squared over 1/4. And now a is the square root of that, and b is the square root of that. In other words, b is 1/2. And a is root 3 over 3. So that's not one they normally give you. They'll give you this as a bonus question maybe, because it's really hard to see. In other words, even when you say it, I'm going to divide top and bottom by 3, everybody's going to write this. Right? But what they're not seeing is that there's already a bottom of 1. Now if I divide top and bottom by 3, I divide that by 3 and I divide that by 3, and that's how I get my 1/3 in the bottom, is that I actually do divide top and bottom by 3. It just comes out to 1/3 in the denominator, not 3. But I guarantee you could give this to 100 math students and they're all going to say divide top and bottom by 3, they're going to stick a 3 under there instead of a 1/3. So 7. 7's pretty straightforward.
is that just knowing the formula, or not the formulas,
There's one secret. Whenever you have a radical, if I say this, what's the domain of that? Take whatever is inside the radical and make it have to be greater than or equal to 0, because that's the restriction. The restriction is you can only take the square root of positive numbers or 0. So whatever is inside has to be greater than or equal to 0. Well, in this case, it's 3x minus 4. Now, this negative 2/3 doesn't have much effect yet on domain. It's going to have an effect on the range. So what's my domain going to be? How do I get it?
Isn't it?
Take whatever inside the radical sign, make it greater than or equal to 0, and then solve that. Solve that equation and you'll come up with the domain, or solve that inequality rather.
It's 4/3.
That's what x has to be. It has to be greater than or equal to 4/3. Okay?
Yeah.
Now, what's the range? What are the possible values for y?
It can't be less than 0.
Yeah, let me get rid of that for a second. What are the possible values for y now?
They have to be at least, or it can't be a negative number.
Y has to be greater than or equal to 0. Always. Okay? Now, in other words, if this is the function. Now, if I stick a negative 2/3 in there, then y has to be what?
Has to be
Less than or
less than 0.
yeah, because, in other words, everything that produces the positive number from that is going to turn negative by multiplying it by a negative 2/3. The fact that it's negative 2/3, it could be negative 100, it wouldn't matter. The negative sign is very important. That means all y values are going to be negative, no matter what x is. could be 0. If x happens to be exactly 4/3, then I got minus 2/3 times the square root of 0, so y can be 0. But it cannot be positive. There's no way the result of the square root can be negative. So there's no way y could ever be positive. Their answers, oh, I see. They give you a domain and a range. Let's see, 4/3 to infinity on the domain, and that one's not right. It's D, or C rather.
Yeah, it's C.
C. All right, a series problem.
The way I did this was I just plugged the top number into the equation, and then figured out if that was the answer to. Like,
yeah, go ahead if you need to. Let me see that.
My dad got it. So we were given a top number and an equation.
Yep.
So I just plugged the top number into the equation.
And you got 129?
Yeah.
For which one?
B.
So when I is 32, yeah, you get 129. And that's the only one that gives you that? Yeah, let's see. A certainly doesn't. C certainly doesn't. D is not going to either. And E can't. So yeah, that's a good way to do it. That's a fast, quick, easy way to do it. As long as there's only one answer that gives you 129 like that. There can be multiple things that can equal the same series or the same sequence. In other words, there isn't just one answer. I could think of another answer that would also equal that exact same series. But in this case, there's only one that equals that series, and that's C.
Yeah, because
hold on a second. Hold on a second. C is not right. Oh, you figured B was right. Yeah.
Yeah.
Yeah. Notice why C is really not right, because it starts at I equal 5. So the first term is 21. So C is not right on all kinds of different counts.
Yeah, if D was 31, then it would be right, but it's not. So.
Well, the problem with D is it's.
Yeah, if it was to equal, like, if the top number was 31,
yeah,
it would be correct.
Right, I get it. I get it now. Yeah. Okay. All right.
But I did do all of them, but I just went back and found the one that was the right name. And
okay, so
it's not the fastest way of doing things, though.
We need to go to the next page, don't we?
Yeah.
So let's close that one out. And snap left on that. Go back to the inbox. Go down to the first one I opened. That one. Okay, that doesn't work. Oh, what happened to it? It didn't pop open even. Huh. I thought I downloaded it. Maybe I didn't download it even. Could have sworn I did. Okay, now I got to get these. Snap left, snap right. This is my least favorable part of Windows 10. Is this where you can only get 2 windows on the screen at one time?
Yeah.
It's totally screwed up the way you blow them up, and then now if I move that line at all, it completely takes away all of my stuff that I blew up. Want to start with 9?
Yeah.
Oh, I love this. This problem always gave me trouble until I finally figured out what the heck, how to do it. And here's the secret. That says f of x, I presume? No, f of x over 2?
Yeah. Plus 1.
Right. Now when you're doing translations, and the point that we're moving is this point right here, 3, 1. When I do this translation, do I affect the x-coordinate?
No.
No, you don't. When I do this translation, do I affect the x-coordinate?
No.
No, only the y. And how about this translation? That is a horizontal expansion. Does that affect the y-coordinate?
No.
Aha. So the secret is to figure out which of these affect which coordinates. Well, we know that we're going to get a vertical stretch on our y and we're going to flip it. So if 3, 1 is in there, we know that minus 2 is the new y, based just on that. And then I'm going to move it up 1, so minus 1 is the final y point. And the only thing that affects the x is that it is a expansion by a factor of 2, making the x what?
6.
6. So 6 comma minus 1 should be the point. And that's the way to handle all problems like that, is to take every single thing that is a translation and figure out, does it affect the x or the y, and then apply it. Starting with your flips first. Notice that I didn't add 1 to that 1 first. I did it last. I wanted to do the flip over the x-axis. So immediately it becomes minus 1. Multiply it by 2, it becomes minus 2. Move it up by 1, it becomes minus 1. Okay?
Does it matter the order between the x and the y?
No. But what does matter is you do all your reflections first.
Okay.
That does matter. And it doesn't matter which one. In other words, if I stick a negative sign inside there, now I have a reflection over the x and the y. As long as I do both of them first, I'm fine. And of course, a reflection over the x would turn that to minus 3 immediately. Then minus 6 because of the expansion of it. Okay, let's look at 10. We've got 12 minutes. Probably not going to be able to cover every one of these in 12 minutes, so you pick.
I think I'm good on the calculator. It's actually, can we just do 11?
Okay. Vertical asymptotes come where?
In the denominator.
Right. It's wherever the denominator is equal to 0. So factor that.
So it's
Factors of 54 that subtract to the number 3.
so it's plus 9 minus 6.
Now, you might be tempted to immediately say that we have asymptotes at minus 9 and 6. But we don't. And here's why. I can factor the top also. The very first factor, that's difference of perfect cubes.
So it's x minus x
Times what?
x squared plus 6x plus 36.
Huh? And now one of my asymptotes turns into a whole. In other words, what looked like it was going to be a vertical asymptote now becomes a whole at 6. So the only vertical asymptote I have is at x equal minus 9. And incidentally, this quadratic that results when you factor a difference of perfect cubes never factors. Don't waste time ever trying to factor that. Whether it's a minus or a plus, it does not factor.
Okay.
Okay? In other words, you could spend a lot of time, well, maybe it'll factor again and take out the x plus 9, but it doesn't, ever. So don't ever waste time trying. I've spent many a time trying before I realized that it can't. So the only answer is B there.
Okay.
As far as vertical asymptotes, the answer is there's a vertical asymptote at minus 9 and there's a whole at 6.
So that helps with the next problem.
Determine the exact values of the wholes. Oh, God, I hate this problem. Oh, that's because you missed Moore's class, yeah.
Don't you just plug it back into the... Don't you just plug the 6 back in the equation?
Now, see what I don't like about this? And I'm beginning to think I'm wrong, but I bet I'm not. X cannot be 6. So when it says determine the exact values of the whole, they're saying, well, yeah, if I plug 6 into this equation on the right, I will get the limit of the function as x approaches 6. That's what you get. In other words, if I plug in 6 for right here,
yeah,
I'm not getting the value of the function at x equals 6. X cannot be equal to 6. That's why it's a whole. What I'm getting is the limit of the function as x goes to 6. That's what's equal to whatever the number is on 12. But the way they write it here, it makes it look like these points are on the function. They're not. X cannot be 6, so you can never have an x value of 6. But you can have a limit of the function as x approaches 6. Obviously, what they want you to do is plug in 6 into the... You've got to plug into this function on the right. In other words, if you plug it into on the left, you get division by 0. You get 0 over 0. So it doesn't do any good to plug in 6 into that. But if you plug it in over here, you do. You get 36 plus 36 plus 36, 108 all over 15, which must equal whatever that fraction is there.
Because then it's plus 5 after that, so it's that would be 36 over 5.
Yeah, I didn't mean to ignore the 5. You have to add the 5 also to all of this. So I know what they mean by number 12. I just don't agree with their concept. There is no exact value of the whole, of the function at the whole. In other words, that's what a whole means. Tell me if you disagree with me, but if I... No, I mean, if I have a function that has a hole in it...
Yeah, and what you're saying makes sense.
Right there, well, that value does not exist, and that value does not exist. So you can't say that when x is 6, y is whatever they came up with, 61 over 5, it's not. It's not correct to say when x is 6, y is 61 over 5. X can't be 6 and y cannot be 61 over 5 when x is 6 either. That's what I take exception with only. And it's the perfect way to describe it is as a limit. In other words, it is correct to say the limit of f of x is equal to 61 over 5 as x approaches 6. But that's all you can say. You can't say when x is 6. And not just Miss Moore. I thought it was just Miss Moore that was doing it. It's all of Chatfield that does it.
Yeah, they all copy off the same book. Like,
yeah,
they literally.
I can't believe that a calculus professor or a teacher of calculus out there wouldn't catch this error though, because this is unless I'm mistaken, I don't think I am, but this is a classical calculus problem. It's a limit problem. It's not a what is the value of y when we're on the hole, because you can't be on the hole. You can only approach the hole.
Did you see the massive binder she had? Or yeah. Did you go into the classroom?
I did, and I got a copy of that.
The entire binder?
Yeah.
Yeah, that's literally, she reads off of that every day.
That's funny. That's exactly what Emma said. In fact, that's what, when we were all together, Emma and her parents and Miss Moore, that's what Emma said. She says, you stand up there and read off that binder. That doesn't do anybody any good.
No, I'm pretty sure she does not know how to do this stuff. She will not do problems that are not in her binder.
Yeah, yeah. Well, I can understand that. I mean, if I'm going to a new tutoring student blind, I'd much rather take problems that I know the answers of and go over those than have to deal with problems that I've never seen before. So I get that. But I tend to agree with you. There's something about this she doesn't quite understand, and it's the limit aspect of it. I just wish somebody would tell her that on this function, it's the limit is equal to the y value as x goes to the x value. It's not the function is not equal to that. And that's all she would need to change is to say that it's the limit that goes there. What's the horizontal asymptote of that function?
Because wouldn't there be no horizontal asymptote? Because the top x is bigger than the bottom x?
Well, if the top x is bigger than the bottom x by precisely 1, which it is, then what you're supposed to do is do the division and deal with the remainder. And when you do this division, you get a linear oblique asymptote. In other words, you can have oblique asymptotes. And the way you get oblique asymptotes is you get a situation like this. You have a vertical asymptote and you have an oblique asymptote. And the oblique asymptote comes from when the numerator is 1 degree higher than the denominator, and you do the division, you can see that the main result is a linear term, x minus whatever, or x plus whatever. And of course, then everything has to move up by 5. So, what is her answer here?
Her answer is D, none.
None, yeah. Okay, good. That's what I would have said also. And she may not have taught you oblique asymptotes.
No.
Not everybody gets them. And so if you're looking for just a horizontal asymptote, yeah, when the top is bigger than the bottom, there is none. There is an oblique asymptote, though, and that it's going to look something like this. And then the curve would be hyperbolic in nature. So the curve looks like this. Something like that. When you have oblique asymptotes. All right, Mitch, I'm going to let you go. And let's see, we have more tomorrow, correct?
No, my final is tomorrow morning.
Ah, right. So we're done for the year. Well,
yeah, or for at least the school year, because I might do the summer stuff.
okay. Yeah, you'll get an email from me that says what my it's going to be the same as it was last year. Package of 4 hours for $80.
Right.
And you can break the 4 hours up however you want. If you want to do a half hour a week, that's fine. Whatever you like.
Because I'm not sure what class I'm taking next year. Because
what are you going to get in your pre-calc class?
I'm going to barely I'm going to get like a 65. So I'm thinking I'm just taking stats.
Okay. Okay.
So I
was going to say, if you're getting a B or higher, you should take calculus. If you're getting lower than a B, I don't know. I actually think you could understand calculus enough to take it, but
yeah, I just felt like I had no base with Miss Moore, and so I would be so far behind starting.
Well, yes and no. I get you caught up real quick. In like 1 week, I'd have you caught up to everything Miss Moore has tried to teach you. And I could get you ahead. I could get you significantly ahead so that the first 3 months of calculus would be review for you.
Yeah,
if you want
I think that's what my mom wants to do for over the summer, is actually like relearn pre-calc.
Yeah.
And then might take it like online.
Yeah.
Like
I haven't seen a whole lot of deficiencies in your pre-calc. Your pre-calc's pretty strong. If I was saying take calculus based on your pre-calc and trig, I would say take it. Because I think your math skills are pretty good, and I think you understand the stuff. I don't really know why you're getting a 65. That could have a lot to do with the fact that it's Ms. Moore. But it's not really based on your lack of math skills. Your math skills are decent. Very good. I'm
getting all the right answers.
65, but
yeah, I'm getting all the right answers on the tests. I just miss like stupid marks. Like in my work, I'll miss like a parenthesis and she'll take off most of the entire
See, your algebra skills are way, way better than Emma's.
Yeah.
Emma's got, Miss Moore was correct that Emma had some problems with her algebra, and she probably shouldn't have been taking pre-calc in the first place. But not true with you. Your algebra skills are great, and your math skills and your pre-calc skills are good. So I don't know. If I were you, I'd give serious thought to trying to take calculus, just because I think it means a lot. All these colleges know exactly what's going on. They know the kids that are taking calculus as seniors, and they know the ones that are taking stats and probability. And I guarantee you there's a difference on their end. So
yeah, I think what my mom's going to probably have me do is work with you on like calculus stuff, and then see if I'm actually qualified enough to get up to that level, and then talk to my counselor first day of school.
I've got some wonderful pre-calc review material. There's a test that colleges use that's called PCE, or Placement Certification Exam, something like that. And it's just a bunch of pre-calc and trig stuff. And it's thick. I mean, it would last us easily 4 hours worth of material. So if you want to do that, I've got the material.
All right.
Okay?
That's what I'll probably do this summer. I'll just have to like text you.
Okay.
And figure out my work schedule and stuff.
Sounds good.
All right.
Mitch, have a good summer and good luck on your test tomorrow.
All right. Thank you.
You're welcome.